Now the last problem of problem set 2.4 from engineering mechanics, solution to 2.65. Then we'll switch on to problem set 2.5 from the next videos. Let me read out the problem and let me remind you certain things that what we have been doing so far in the projection problems. Two cylinders of weight Q and R. These are two cylinders. Its weight is Q, its weight is R, vertically downward passing through the center of gravity. And these two cylinders are connected by a bar from here to here. This is a bar. This one. This is a bar which is connecting the two rods. Connected by a bar of negligible weight. Its weight is not neglected, so we will not consider. Hanged to each other, each cylinder at its geometric center. Geometric center of the first, geometric of the center of the second. The bar is connecting the two cylinders. Determine the magnitude of force P. What force P we should apply here, making angle 65 degree with this direction to the center of the cylinder R to keep the cylinders in equilibrium in the position shown in the figure. This is the figure V in your book. The following numerical data are given. Value of Q is given, value of R is given. This angle is given as 50 degree, this is given as 60 degree, and this is given as 20 degree. So what I should remind you, so far we have been doing the method of projections. Means, first of all, you have to find out the points of contact where some forces are acting. And if there is a force like this, and here if you draw x-axis, and if you here draw y-axis, supposing this angle is theta, then if you drop a perpendicular, then this component, by taking cos theta in this triangle and cross multiplying, this component of f comes out to be f of cos theta. And if you drop a perpendicular here on y-axis, then this component of f comes out to be f sin theta. That's all. This is so given a vector, you can split it into two rectangular components, f cos theta, f sin theta along two perpendicular axes. Then apply sigma x is equal to 0 and sigma y is equal to 0 to find out the different values. So I have redrawn this diagram for better understanding. So let us look at it. So let me explain. This cylinder, its weight from the center of gravity is Q, 2000 Newton. Here is a point of contact. This angle is given as 70 degree. Since this is perpendicular to the horizontal, this angle is 90. So here at the point of contact, the reaction force RA, I have shown it to this side, passing through the point O1. So here this is 90 because this is normal. This reaction force is normal to this curved surface. Now, then how this angle is 70. Now this is 90, this is 70. So, if you look at this quadrilateral, this one, if you look at this quadrilateral, the sum of the four angles will be 360. This is 90, this is 70. So this will be, since this is horizontal, this will be 110. So 110 plus 9200 plus 9270. So here we are left with 70. Then this angle was given as 20 degree in the book. So this line is parallel to this line, and this transversal, which is transversal, will make 20 degree here if you draw a horizontal dotted line here. Now what is this transversal S representing? So I am explaining here, since the bar connecting the two centers, this bar from O1 to O2, connecting the two centers O1 and O2 is under compression, because here there is a force like this, and this bar from O1 to O2 is under compression. So this the compression force S, the axial force S, will be towards each cylinder. For this cylinder, this S is to this side, and for this cylinder, this S is to this side. Now then comes how this angle is 70, this is 70, this is 20. If you draw a dotted line here, this is perpendicular, so this angle is vertically this 70, this line and this line, they make angle 70 here, so this is vertically opposite, so this is 70. Now this is 20, and this dotted line is perpendicular to this, so 90 minus 20, we are left with 70. So now we can apply the free body diagram at O1. Then let me explain here, then we will finally come to apply free body diagram at O1 and O2. Now, how this angle is 50? Given this is 50, how this is 50? If you look at this quadrilateral, I'm moving my pen on it, right? This is 90, this is 50 here, so I am left here, this one will be 180 minus 50, that is equal to 130, 130 plus 90 plus 90. Then this has to be 50 to make the sum of the four angles 360 degree. And if I extend this line to the right hand side as shown dotted, this will be vertically opposite to this. Since this is 20, this is also 20. And this is given as 65. Now let us apply the free body diagram and solve different values. Now, therefore, S is the axial force along the bar acts towards each cylinder. This axial force, the bar O1, O2, due to compression, has an axial force acting towards this cylinder, So at the point O1, I am drawing the free body diagram. This is your O1. The Q is acting vertically downward. This is your x-axis. This is your x-dash. This is your positive y-axis. This is your negative y-axis. So I just explained how this angle is 20, this angle is 20, this is 70, 70. So apply sigma x is equal to 0. If you apply sigma x is equal to 0, means the component of R along positive x-axis, this much, will be RA cos 20. Or you can say same thing as, if you look at here, if you consider this angle, this is same thing as this. Either you say, taking this as the angle, either you say RA cos 20, or taking this angle, you say RA sin 70, one and the same thing. So RA sin 70, and the component of this along negative x-axis is equal to S cos 20. Sin 70 same thing as sin cos 20, the numerical values. So RA is equal to S. Now it is because the value of cos 20 and value of sin 70 are equal. You can check with a calculator, or you can write it as sin 90 minus 20. Sin 90 minus theta is same thing as cos theta, that is cos 20. So they are cancelled. Now apply then sigma y is equal to 0 at the same point O1. Means Q is already along negative y-axis. The component of x along positive y-axis will be this much, will be S of cos 70, and the component of RA along positive y-axis, if you drop a perpendicular here, will be RA cos 70 or RA sin 20. So sigma y is equal to 0. So sigma y is equal to 0. So sigma y, have a look. Sigma y is equal to 0. RA cos 70 plus S cos 70 is Q. Value of Q is known. And since we just proved RA is equal to S, so for S I substitute RA. RA cos 70, RA cos 70. 2 times RA cos 70 is equal to Q. So RA is equal to Q over cos 70. Put value of Q is given. Put the value of cos 70 in a scientific calculator. This comes out to be 2923.804 Newton. And since RA is equal to S, both are equal. So S is also equal to the same value, 2923.804. Now free body diagram at O2. O2, there are 4 different forces. Let me show you the original diagram. At point O2, there is a vertically downward force, the weight R. Here, this is your P, making angle 65. This is to be found out. This is to be found out. And your RB, which is normal to the surface at the point of contact B. The normal reaction is RB is pointing to this side. Pointing to this side, making this angle is 50. So it's vertically opposite angle. This will be also 50. This will be also be, sorry, not this one, not this one. This will be 50. This is same thing as this line. This is same thing as this line. Here the angle between them is 50. So this is vertically opposite. So this one will be 50. So in the free body diagram, I am showing that. So in the free body diagram at point O2, I have drawn the x-axis, the x-axis, y-axis. This is your S acting towards the smaller cylinder. This was your P, making angle 65. This is to be found out. This was RB. I explained how this is 50. If you are worried how this is 65, you may look at the original diagram. How this is 65, if you extend this line, then this is vertically opposite to this. So this is 65. That is what I have shown here. So now it is pretty simple. Now apply sigma y is equal to 0. First apply sigma y is equal to 0. Take the y component of RB to this side. This will be your RB cos 50. And that is being opposed by R to this side. And if you drop a perpendicular from here, from this point to this point, will be P times cos 65. And P cos 65 and R, they are in the same direction, so they are added. Then if you from here, if you drop a perpendicular, this much will be your S times sine 20, right? So take cos 50 to the right hand side, it is divided. Now put the value of R, keep it as such. Put the value of S which you calculated, sine 20 divided by the cosine of 50. Now put sine 120, multiply with 2923.8 and add this to 1000. We get this much plus P times cos 65 divided by this. Now A plus B by C. A plus B by C we know is equal to A by C plus B by C. So this divided by this gives you 3111.48. Then this divided by this will be P times cos 65 over this. Put the value of cos 65 in a scientific calculator, divide with this, you get this much, and here is P multiplied, so P times this. Now, so RB is found out. Now apply sigma x is equal to 0. Sigma x is equal to 0 at concurrent point O2. Means x component of RB will be along negative x-axis. X component of S will be along positive x-axis. And the x component of a P will be along negative x-axis. So these two will be added, and that will be equal to this value, that is S of cos 20. Now, so sigma x is equal to 0. S of cos 20 is equal to RB sin 50 plus P times this. P P times this. So put S as this much, RB as this much, which we calculated in the previous page, and put cos 120, sin 50, sin 65 from here to find the value of a P as 258.26 Newton. Thank you. Some of you have, if you like the videos and if you find the solutions are interesting and is helpful for you, please give your feedback, and if you still like, you can subscribe if you have not. Thank you.